So here's a circuit that we're given. It has a 2 voltage sources, 6-volt source, and a 2-volt source. And we are asked two things of this circuit. First, they want us to use superposition to find the current in the 600 ohm resistor. So that's this resistor here. And then after that, they want us to find the Thevenin equivalent of the circuit if we were to remove that 600 ohm resistor. So first we're looking for the current that's flowing through there, and then next we're looking for, if we removed it between these two terminals, what would be the equivalent Thevenin equivalent circuit attached to those terminals. So let's see what we need to do this. So right off the bat, we see that we have this 1000 ohm resistor in parallel with the voltage source. And anytime you have a resistor that's connected across a voltage source, unless we're interested in the current in that resistor, it really has no bearing on what happens in the rest of the circuit, because it'll always have the same voltage drop across it, which would be the same as the voltage source. So that being the case, for this problem, we can basically act as if it is not there. So we can just say this 1000 ohm resistor really has no bearing on what we're looking for at this point. So now, with our new revised circuit, we want to start applying the principles of superposition. So first we want to look at this voltage source, the 6-volt source. And so remember, when we're doing superposition, once we pick a source, the other sources, if it's a voltage source, we short it out. And if it is a current source, we open the circuit. So in this case, we have the voltage source. So we will take that source and act as if it is a short. So we do it like this. And so remember, we're looking for the current here in the 600 ohm resistor. So to do that, we first need to find out what the total current is coming from our source. So this will be IT. And so to do that, we're going to need to find out the equivalent resistance seen by the source. So we'll call that RT1 for source 1. And what we have there is, looking out from this source, we see we have a 900 ohm resistor, and then that's in series with a 300 in parallel with a 600. And so if we write that out, we'll have 900 plus 300, 300 plus 600, and then that's over 300 times 600. And so when we solve for that, it's going to be 900 plus 200, and so that's 1100 ohms. So that means what the resistance this source sees is 1100 ohms. So therefore we can solve for this I total from the first source. Remember, that's just Ohm's law, so it's voltage over resistance. So in this case, it's 6 volts over 1100 ohms. And we could rewrite that then as 3 over 55. Oh, excuse me, one too many. 3 over 550. And we'll leave it at that. Okay, so that's the total current. So now the current through the 600 ohm resistor, the I, we'll call it 6-1. That's going to be, once it gets to this node here, we see that it's just a current divider. So we can apply the principles of current division to this. which is it's the total current times the resistance, which I call other, which is the other branch that we're not interested in, over the R of the total of everything in the current division. So in this case, it's going to be 3 over 550 times 300, that's the branch we don't care about, over 300 plus 600. And so that's going to be 3 over 550 times 300 over 900. And so that, bringing this down here, is going to equal to 3 over 550 times 1/3, or 1 over 550 amps. So this is the current through the 600 ohm resistor from the 6-volt source. So that's half of the first part of the problem. Now we need to consider the other source. So to do that, we'll reset our circuit. And again, we can continue to ignore that 1000 ohm resistor that we took out earlier. But now we want to consider the 2-volt source. Oh, and one thing I should note is this 550 amps, because of the polarization of that voltage source, it will be going downward through the resistor, or down page. Okay, so now when we're looking at the 2-volt source, remembering when we do superposition, we short out any other voltage sources. So that being the case, the 6-volt source is going to go away and be replaced with a short circuit. So it would look like this. So now we have very similar to what we had before, so we'll approach it the same way. So we need to again find the total resistance seen by our 2-volt source. And looking this way actually. So looking out from this way. So when we do that, we see that we'll have a 300 ohm resistor, and that's in series with a 600 in parallel with a 900. And so when we work that out, that'll be 300 plus 600 plus 900 over 600 times 900. And when we work that out, that'll be 300 plus 360. And so that ends up being 660 ohms. So as before, we can do the total from the second source. Again, that's V over R, and so that's going to be, this time we'll say minus 2, and that's going to be over 660. So that'll be a minus 1 over 330. So that's our total current coming out of the source here. So coming this way, and it's negative, so it means it actually flows the other direction. But we'll take that into account here in a minute. So now we can find our current through the 600 ohm from the second source, same as before, applying this principles of current division. So we already know we have a minus 1 over 330, and then the resistor that's the other that we're not interested in is the 900 ohm. So it'll be 900, and that's going to be over 900 plus 600. And so when we calculate all this out, what we find then is we have a negative 1 over 550, which really means we could say that as 1 over 550 in the upward direction, such that our total current through the 600 ohm resistor is going to be I61 plus I62, and so that'll be 1 over 550 minus 1 over 550, and so we have 0 amps going through the 600 ohm resistor. So that is the answer to part 1. So now we want to consider part 2, where they want us to find the Thevenin equivalent for this circuit. So let's reset our circuit here. Again, don't have to worry about the 1000 ohm resistor that we took out earlier. It really doesn't have any consequence on our circuit. So now what they're saying is, if we were to take the 600 ohm resistor out of the circuit and we're just left with terminals, which I'll do them in red, here and here, what would be the Thevenin equivalent seen by that circuit? So to do this, we first want to find out what the total current flowing in the circuit is. So it's the current flowing around the circuit this way. So we can find that then. I total is going to be just the voltage over the resistance. So our total voltage is, we'll have 6 volts, and then going in the same direction as we go around here, you see it's in the same, pushing the current the same direction. So 6 plus 2, and then that's going to be over the total resistance, which is 300 plus 900. And so when we calculate that out, that's going to be 8 over 1200. And we can divide a 4 out of those. So that's a 2 over 300, or 1 over 150. So 1 over 150 amps. So now we should be able to calculate the Thevenin voltage, which will just be the voltage drop from one terminal to the other. So that would be the voltage drop across this open gap here. So to get that, we're going to do, let me use a different color, use green. We're going to look at this loop here, right there. And so when we do, we see we have 6 volts, and then we see minus 900 ohms, which is our resistance, which again is just Ohm's law of E equals IR. So we've got the R, so we need the I, which was 150. And so when we calculate that out, that's going to be 6 minus 6. So the Thevenin voltage is equal to 0 volts. 0 volts. So now we need to look from this, from these terminals here. If we were to short out the voltage sources, is what we do when we find Thevenin resistance, and then calculate the resistance. And so what we have then is we have our terminals here. We come up and we have a 900 ohm resistor. So that's 900, and then we have our 300 ohm resistor. So you should be able to see that those are in parallel. So that means that our R Thevenin is just going to be 300 in parallel with 900. That's going to be 300 plus 900 over 300 times 900. And when we calculate that, we should come up with 225 ohms. And actually, let me rewrite that. I wrote that backwards. just so you won't get confused if you're trying to work it. It's going to be 300 times 900 over 300 plus 900. And that comes up to 225 ohms. So if we were to draw the Thevenin, here's those original terminals where the 600 ohm resistor was, we would have just a resistor there between the terminals. It would be a 225 ohm resistor.